Hello everyone. This question has been taken from Irodov Fundamental Equation of Dynamics, question number 67. Question is, a bar of mass m is pulled by means of a thread up an inclined plane forming an angle alpha with the horizontal. Inclined plane is making alpha angle from the horizontal. The coefficient of friction is equal to K between the bar and the inclined plane surface. Find the angle beta which the thread must make from the inclined plane for the tension of the thread to be minimum. And what is it equal to? So let us solve these questions. So we should make the diagram and show all the forces acting on bar. So forces acting on bar is the component of the gravitational pull along the inclined plane is mg sine alpha. Perpendicular to the inclined plane is mg cos alpha. Normal reaction force from the inclined plane to the bar is N. And T is the tension applied to the thread for the pull. So T will be having two components, T sine beta perpendicular to the inclined plane and T cos beta parallel to the inclined plane. We have taken y-axis perpendicular to the inclined plane and x-axis parallel to the inclined plane. So what should be our target basically? So when we are applying T and it is talking about the minimum T, so one thing will be we should apply that much T, that much pull on the thread which should create a tension force T enough to move it with a constant velocity up along the inclined plane. That will be the first thing. As second thing, beta should be selected in such a way so that T applied should be minimum. So when you are applying the pull on the thread as T in this direction, what is happening? A component of it perpendicular to the inclined plane T sine beta will reduce the normal reaction force from the inclined plane. So means if your N is decreasing, your friction force which is coming up on this due to the movement of bar up along the inclined plane will be minimum, right? So our target should be to obtain T as a function of beta and differentiate it to get the and differentiate and equate it to 0 to get the minimum. So I have just written a write-up as well, so you can go through, you can easily understand. Given in the question is mass of the bar m, coefficient of friction k, angle of inclination of the inclined plane alpha, angle, and to find is angle beta for which T will be minimum. So our target should be to obtain T as a function of beta and use mathematics to differentiate T with respect to beta and equate it to 0 to get the minimum value. Also for T to be minimum, it should be just enough to set the motion of the bar to move up with a constant velocity up along the inclined surface. So we will write now Newton's law of motion in y direction. So all the forces in y direction. T sine beta is in the positive y direction. Normal reaction is also in the positive y direction. So these two are plus. Mg cos alpha is acting in the negative of the y direction. So minus mg cos alpha will be equal to m into acceleration in the y direction, but there is no acceleration in the y direction because all the time bar is in contact with the inclined plane and moving up due to this applied T against these forces. So Ey is 0, so you got number 1 equation, n is equal to mg cos alpha minus t sine beta. Now we will apply Newton's law of motion in the x direction. So positive x direction, t cos beta is acting in the negative direction, minus mg sine alpha, negative direction, minus f m into ax. Since the t has to be minimum, so it should move with a constant velocity up along the inclined plane. So acceleration in the x direction is 0. So t cos beta, we got this mg sine alpha plus f, but we know that the sliding friction value is k into n. So mg sine alpha plus k into n value you can put from equation 1 and solve it for t. So this is the equation you got. Now if you see, only thing in number 2 equation is the beta which we have to determine to make t minimum. So only beta is the variable and it is in the denominator of this equation. So if denominator of this equation is maximum, so t will be minimum, because rest other things, see here, mg is constant, alpha is constant, k is constant. So only beta we can play with, right? And since it is in denominator, so we should work for this to be maximum so that t is minimum. So we will differentiate the denominator with respect to beta and equate it to 0. So I've left the calculation on you. Upon solving, you will get tan beta is equal to k. Okay, this is equation 3. Now this equation in equation 2 you can use, so you will get t minimum. By putting the value tan beta is equal to k, you will get this. So this is your answer. Okay, so tan beta you can think of like perpendicular by base. Perpendicular is k, base is 1, so your h hypotenuse will be 1 plus k square under root. So this, so after putting cos beta and sine beta in the terms of k, we can get the equation here. So this will be your final answer. I hope you understood the concept. If any problem, you can just write in the comment box. I will explain. Thank you.